Hello, I'm Officer Cadet Martinez John, and in this lesson we will learn about aircraft controls. So first we have what we call ailerons. So ailerons are the control surfaces that are attached to the trailing edge of the wing, or the back, and near the wing tips, or right at the edge. Okay? They move in opposite direction, so as one goes up, the other one tends to go down. They are controlled by movement of the control column or the stick, and they serve in roll. So as your control column is moved to the right, then your right aileron goes up, your left aileron will go down, and you will roll to the right. As you move your control column to the left, then your left aileron will go up, your right aileron will go down, and you will roll to the left. So what we're essentially doing here is, so let's say we're doing a roll to the left, then we're actually making the right wing create more lift than the left wing. So the result is going to be a rolling motion. The elevator. So the elevator is the control surface hinged at the trailing edge of the horizontal stabilizer. It is controlled by the forward or aft movement of the control column. So when the control column is pushed forward, the elevator will go down and the nose will also go down. When the control column is pulled back, then the elevator will go up and the nose will also go up. So what we're essentially doing here is we're changing the amount of lift generated by the tail. So when we push forward and the nose goes down, the tail is generating more lift than the wings, which results in a pitching down motion. And vice versa, when we pull up, then the elevator is creating significantly less lift than the wings, and the result is we go up. The stabilator. So what the stabilator is essentially a horizontal stabilizer and an elevator all into one. So the whole entire surface moves. So it still moves up and down just like an elevator would. The rudder. So the rudder is situated in the back of the fin, or the vertical stabilizer, and it moves the nose of the aircraft left and right in the motion known as yaw. So when we push the right rudder pedal, the aircraft will yaw right, and the rudder will also fully deflect towards the right. When we apply left rudder, then the rudder will deflect left and the aircraft's nose will yaw left. Okay. So the rudder is used in conjunction with ailerons to achieve coordinated turns. So this is important, especially when it comes in a glider. Because in a glider, if you don't have coordinated turns, you will tend to drop faster because of increased drag. And in a glider, you really don't want that. So whenever let's say we're rolling to the left, we apply a little bit of left rudder in order to keep us coordinated. The coordination ensures that the airflow going over the wings is not coming at an awkward angle. And now just maximize our lifting percentage. Trim tabs. So the purpose of trim systems is to assist the pilot by eliminating excessive pressure on the flight controls. So for example, usually on air tow, you have to keep a lot of forward pressure on the stick to the point that your hand starts to shake. So what trim tabs do is they help you maintain that forward pressure. Think of it kind of like cruise control on a car. So you set your trim tabs, if you set them properly, the aircraft will maintain a certain amount of forward pressure, which will translate into a certain amount of airspeed. So it will maintain that airspeed. So how this actually works, there's kind of like a little teeny elevator attached to the big elevator itself. And the trim tabs will tend to point in the opposite direction that the elevator does. So if you trim so that the elevator points up, and it's kind of like that will be a nose-high attitude, then the trim tab will be pointing down. And vice versa, if you're trimmed so that the elevator points down, and the trim tab will be pointing up. So what we're essentially doing is we're changing the amount of lift generated by the elevator itself, or by the tread time essentially. And that extra lift is pointing or helps us keep the elevator at a certain angle. Alright, next up we're going to learn about aircraft axes. So first we have the longitudinal axis. So this axis here is an imaginary line. In this case it runs from nose to tail and passing through the fuselage neck. So movement around this axis is what we call roll. So when you think of movement around the axis, think of the axis as the tip of a top. It'll stay there and everything will spin around it. So movement around the longitudinal axis is roll. Another thing that might come up though is movement of the axis. So when you're asked about movement of the longitudinal axis, then that will be pitch, because the whole axis is actually moving. Similarly, we also have the lateral axis. So the lateral axis is another imaginary line, only this one extends from wingtip to wingtip. So movement around this axis is what we call pitch. So the axis doesn't move, everything moves around it, resulting in pitch. And similarly, we also have movement of the lateral axis. In that case, then that will be roll, because the whole lateral axis is moving. So that way they're kind of related. So roll is, for example, movement of the lateral axis and about or around the longitudinal axis. And similarly, when we have pitch is movement around the lateral axis and of the longitudinal axis. And finally, we have the vertical or normal axis. Since we're working in 3 dimensions, then we need 3 axes. So the vertical axis, or also known as the normal axis, is the imaginary line that goes from the top to the center of gravity and down. So movement around this axis is what we call yaw. So when it comes to movement of and about, in this case then it's just straight out yaw. The only ones that work with of and about is the longitudinal and the lateral axis. Adverse yaw. So whenever we enter a bank attitude or a roll, then the aircraft will have a tendency to yaw away from the intended direction of turn. So the reason for this is aileron drag. Remember, when we're in a roll, let's say I'm rolling towards the right, then the left wing is creating more lift than the right wing, which is why we roll to the right. However, when we have more lift, you also have more drag, which results in a yaw to the left, which is not where we want to turn. Again, this is called adverse yaw. In order to correct for this, then all we do is just apply a little bit of rudder. Essentially, so when we apply, let's say we're turning to the right, we apply right rudder, and we will yaw to the right where we want to go, essentially. Alright, balance controls. So controls are sometimes dynamically balanced to help the pilot in moving them. So for example, we can have something that's called a mass balance. So what that is kind of like a streamlined shape that's fitted on the front of the aileron, right at the hinge. So what that does is it adds a little bit of forward weight, which makes it much easier to actually deflect the control surface. So it is often fitted in ailerons. Then we have what we call a static balance. In a static balance, the control surface itself has a specific COG which helps it deflect itself without having any airflow over it. So in this case, the control surface itself is balanced such that it will not have much weight towards the rear, which will make it much difficult to deflect the control surface. In this case, the weight will be much more forward, just built in, and it doesn't require any airflow, unlike the mass balance, which requires airflow to help it deflect. Alright, that is all. If you have any questions, comments, concerns, queries, or random outbursts, feel free to comment in the comment section down below. Thanks for watching and happy landing!